it's always, the story always starts with pressure, and then we look at wind, and in the positive phase, the wind generally is very strong, and in the negative phase, what would we expect? So Liana yesterday volunteered to be trade winds. But okay, someone else. What do we expect in the negative phase generally?
If it's an El Nino phase, then you expect.
And that would be a negative phase,
yes,
right?
So zero trade winds, very slow, very
weaken. Yes, exactly. We're always thinking weak in negative phase of whichever climate oscillation I'll be talking, and today I'm talking about 4 more new ones. But in the positive, we're always talking about an enhanced pressure gradient. So that means with a more steep pressure gradient, we generally have more increased winds. And obviously, with winds, the next part of the story becomes in the ocean. When there's wind, the water blows on one side, okay? And then what happens when there's strong winds? Who said that? Okay, yes, upwelling will occur. So you can already pick up now the line, how it's going to happen. You're looking at your pressure, your wind, your upwelling. These are generally the characteristics you want to talk about when you talk about this climate oscillation, okay? So today we talk about southern annular mode. Let me put that here. Those are our different climate oscillations that we need to complete for this course. Yes?
For the test on Friday, are we going to be tested on everything up
yes,
to
yeah.
today?
Up till hopefully today or maybe tomorrow. Yes. So yesterday we looked at trade winds, okay, which happens in the Pacific region. Now, if you remember with Professor Katie's section, we had looked at Hadley cell. What was the next cell? Do you guys remember? Hadley cell and then Ferrel and polar cell, right? Okay. So with those cells in the atmosphere, this is what determines our different pressure system, and this is what generally determines our wind system. This is why we had trade winds along the equator. But now we're looking at around this region, okay? So around this region, around 60 degrees or 50 degrees latitude in the south, which is around here generally. The roaring 50s, have anyone ever heard of that? It's a very dangerous, yeah. Yes? You want to
say my dad was in the South African Navy
oh.
many years ago, and they used to go on the big ships.
Yeah.
They still worked. And they'd go like into the roaring 50s, and he used to say like the wave would swallow the whole boat.
That's so cool. In Navy.
Yeah. That's
actually really cool. So I've also experienced the roaring 50s, and it's a bad memory. You just eat a lot of ginger biscuits and you try not throw up. It's really moves a lot. Even your glass of water on the desk is like moving. But okay, which ship was your? It's a Navy military ship, right? Okay, I love Navy ships. So I was on the essay Agulest. So we have a roaring 50s, which generally are driven by these westerlies. Now, let's make a little map of it so that we understand what we're talking about. If we have my Antarctica, it's going to be here, and generally over here. And we're going to pretend here is South America. South Africa is going to be here, and Australia is going to be here. South America. And this one is the subtropical front. The subtropical front, STF, is generally like a front in the ocean, which is boundary between this warm, salty layer. And that's generally also where our westerlies are flowing. That's our wind system, okay? Now, when we think of a positive phase of SAM, okay, think a little trick. P is poleward, okay? So your STF and your southwesterly winds, okay, is going to move poleward, okay? So it's going to be much closer. It's going to be much closer now. This is where our subtropical front is going to be, and that's where our wind, westerly wind, is going to be. Okay? And you would have a low pressure system here, and you would have a high pressure system here. Now again, the story goes the same as Enzo. With high pressure, you know what atmospheric conditions are coming, and with a low pressure, you know what atmospheric conditions are coming, right? Anyone want to tell me what do they entail? We'll get a book. Low pressure? Anyone? Yes, Liana.
When you have low pressure, there will be like more precipitation.
Yes. Moisture.
Moisture, yeah, because warm air rises.
Exactly. Exactly. Low pressure system, the air is hot and it's going to rise. So that's also always something maybe to, there are little tricks you can find how to remember it, but it's actually very logical. So with low pressure, it's always moisture, storm activity, precipitation, snowfall. So we are looking at storm activity here. We are in the positive phase, hey? And remember, positive poleward. So storm activity going on here. Now, remember, with a pressure gradient, we have our winds, but now we have an increased wind, because in the positive, generally we're looking at increased winds. With increased winds, what did I say next comes into the water? Come on, guys. Upwelling? Okay. So we will have an increase in upwelling, because generally in the southern hemisphere with Ekman transport, if the wind is blowing this way, it's going to be the water at the surface is going to be deflected to the left, and then the water from bottom will rise. So if you see here, you're very close to the coast, and that's our wind. The water is going to move this side, and then the water from below moves up, okay? And the water from below, by the way, is circumpolar deep water. Okay, we're going to get to this one in a minute. Now, I said high pressure system up towards, let's look at Patagonia, for instance, because it's a region of which has glaciers. I don't know if you guys like to watch those travel vlogs. I really love watching those. So there's a lot of glaciers hiking you can do over there. If we have high pressure system, we now have a reverse of no moisture, no storm activity, no precipitation, and which means that the glaciers will recede, okay? So there'll be less glaciers happening because there's no amount of snow accumulating in the glaciers. So that's also something to note by what's going on in those regions. And what's going on over here is an increase in storm activity and increase in upwelling. Now, CDW, circumpolar deep water. That particular water, so you've learned that denser water sits at the bottom and less dense water is generally higher, right? And that's generally warmer water, which is less dense, and colder water, which is more dense, okay? But in terms of salinity, what do you think increase or decrease the density? Yes?
I think high salinity water is more dense.
Yes. Pretty logical, right? It'll be more dense with more, yeah. So The circumpolar deep water, the problem or the trick about it is that it's actually warm. In the Antarctic region, like it or not, the surface waters are much colder than some water mass which is at the bottom, and which actually happens to be, in this case, the circumpolar deep water, which is warm. But even though it's warm, it's still denser than the surface water because it has a high salinity level. And it sits just above, for those who know their water masses. I don't know if you guys have covered water masses. A little bit, you must have. This is basics physical oceanography. Antarctic bottom water is just underneath. And then you have circumpolar deep water, which is just above. And then you have your other waters coming up. So now this water mass upwells and comes to the surface. But the problem is it is warm. So if it is warm and it comes to the ice, what would it do? Yes, it will melt it. It will actually result in melting of some regions. So this is just something to also note that even though that upwelling is happening. So I just explained my STF and my SWW, so my southwesterly winds, which were moving poleward, but now in a negative, they're going to move in a negative phase of the sound. It's now going to move north, towards north, okay? So just actually to make it more less confusing, just like that. Okay. Now my subtropical front is now over here, much higher up, okay? And my southwesterly wind are over here. Okay, and I'm gonna have a low pressure system over here, and I'm gonna have a little bit higher pressure system over here. Okay, so if now I was having strong winds in the previous one because of a steep gradient, now it's like a much longer difference. It's gonna be much more weakened winds. So the southwesterly wind, it's going to be much weakened right now, okay? Meanwhile, we have low pressure system. So as Liana just mentioned that we will have moisture and precipitation, now we would expect to see snowfall and precipitation in regions like Patagonia, where the glaciers are there and they're going to have advances in the glaciers. Okay, that's in terms of a low pressure. We obviously are going to have a decrease in upwelling now because there's less winds. Okay, so more storm activity over here. There's going to be like frontal, like yesterday what we were experiencing is this cold front, which is coming again from those Antarctic system. So again, a similar thing, we would expect more of this frontal system, which is associated with moisture. So more storm activity to be seen in a negative phase, less upwelling, okay, less, and a higher pressure here with drier conditions over here, obviously, because you're always associating this with dry, and less winds, obviously, more importantly. Okay, so now let's look at it in the slides together.